Hi guys, welcome to the last session of Matrices. This is session number 11. In this session, we are going to use all the theory that we have discussed in the last 10 videos and try to solve the questions that have actually come in IPMAT 2019 and IPMAT 2020. I believe there are about 6 questions that have come in these 2 years. Okay, so let's take a look at the questions that have come. The first question, okay, this is about me. I have shown enough about me. Let me move forward. The first question we're going to have today is from the IPMAT 2019 paper. Now the question here says, let A, B, C be 3 4x4 matrices. Okay, they are 4x4 matrices in such a way that determinant of A is known as 5, is given as 5. Similarly, determinant of B and determinant of C are given. The values are given. They are asking you the value of this product of matrices as an answer. And if you notice, there are no options. So this was a short answer question. If you want to solve it, pause the video and you can try to get an answer. All right, so those of you who want to continue, let's see what is the process here and what are the properties I'm going to use to solve this question. The first property I need to remember is splitting of determinants when I'm trying to look at multiplication of matrices. So determinant of A into B, I can write it as determinant of A into determinant of B. So I can write this entire thing split up into determinants. So this property, the next property I'm going to use is determinant of a matrix raised to the power of n is equal to the determinant of a matrix whole to the power of n. So I don't have to do C cube, that means. I can just write determinant of C, then raise it to the power of 3. That is the meaning. The next property I will use is when I'm multiplying the matrix with a constant, I can take the constant outside. So this is supposed to be k power n. Okay, please keep in mind this is supposed to be k power n. Okay, it's not k into n, it is k power n. Right, so that's the next property I'm going to use. I'm still not done. I have another property to use. Determinant of A inverse is 1 by determinant of A. We have seen this in the properties. And the last property I want to use is determinant of A transpose is determinant of A. These are the properties I want to use to solve this question. So first, I will call 2A as one item or one grouping, and I will use this particular property. So I can write it as determinant of 2A into determinant of B inverse into determinant of C cube into determinant of B transpose. So I have used the first property and I have separated the terms. Now I will use K into A property. So this becomes 2 power. Now what is the dimension of A? The dimension of the matrix is 4 by 4. So 2 power 4 into determinant of A multiplied by what is determinant of B inverse? I will use this property. It becomes 1 by det of B into what is determinant of C cube? I will use this property here. This becomes determinant of C whole raised to the power of 3. And finally, determinant of B transpose, I will use this property, is nothing but determinant of B itself. Now determinant of B, the values get cancelled clearly because you can see it is -3. So -3 will get cancelled. I will be left with 16 into determinant of A is 5 into determinant of C is half whole cube, which is 16 by 8 into 5, and this is 10. So the answer to this particular question is 10. In an exam, you should ideally be able to solve this question within about a minute and a half if you are thorough with the properties. If you notice, I have used inverses in this, but I did not use how to calculate an inverse. I already mentioned in the inverse classes, in the inverse class, that mostly the paper will not ask you to solve the inverse, but you will end up using the properties. So that is the most important part in the entire matrices, understanding and remembering the properties. All right, let's move on to the next question. The second question is somewhat like this. If A is a 3 by 3 non-zero matrix such that A square is 0, this is number 0, then the determinant of this entire thing looks scary. It might look very, very long. Now this is not 1, here it is I. I means identity matrix. I means identity matrix. So they are basically saying I plus A whole power 50 minus 50A is how much? Now, recollect your binomial theorem. Your binomial theorem says I can expand this in the below format. 50C0 I power 50 plus 50C1 I power 49A plus 50C2 I power 48 A square, and so on. Last two terms I will write 50C49 I and A power 49 plus 50C50 A power 50, and then finally you have a minus 50A. Now the property of an identity matrix, you will remember that identity matrix multiplied to any power n will be the same identity matrix. So the power does not matter for identity matrix. So this will become 50C0 I itself, right? Plus everywhere else all powers of I will become simple I. And the other property of an identity matrix is I into A, any matrix will be A itself. That is a property of an identity matrix, which means the second term becomes 50C1 I power 49 is I, and I into A is A itself. So everywhere else you will be having only A, 50C2 A square plus and so on up to the last two terms 50C49 A power 49 and finally 50C50 A power 50 minus 50A. Right, till here it's clear. Now 50C1, so let's look at the powers of A. Now A square is 0, so clearly this entire thing is 0. And from here, if you notice, if A square is 0, then A cube is nothing but A square into A, which is again 0. So all higher powers of A are zeros. All powers of A are zeros. So this will straight away become 50C0I plus 50C1A, and everything else, all of these, wherever there is a power of A more than 1, those are 0. So all of them will get or vanish. They will vanish. So the only thing left out will be minus 50A. Now, if you simplify this further, 50C0 is 1. 50C0 is 1, which is I, plus 50C1 is 50A minus 50A. This will get cancelled. You entirely, the given expression becomes simply I. The entire expression will become simply I. They are asking you the determinant of the final value. So you are supposed to find determinant of this entire expression, and you realize that the entire expression is nothing but identity matrix itself, which means you want determinant of I. And any determinant of I or determinant of any I, it doesn't matter, it's a 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix, any identity matrix is always 1. So the answer to this question is 1. Once again, this was asked in a short answer of 2019 itself. Right? Let's move ahead. Next question. Okay, let's look at this question over here. If a 3 by 3 matrix is filled with only plus ones and minus ones such that the sum of each row and each column in the matrix is 1, then the absolute value of the determinant is. The absolute value of the determinant is. So they are asking you the value of the determinant without the negative sign, if at all there is a negative sign in it. So first, let us focus on getting the determinant in order. Pause the video if you want, try to check out your answer. Okay, so let's try solving for those of you who could not get the answer. Now, I want to fill a 3 by 3 matrix in such a way that any row or any column will be filled with only plus and minus ones, and the sum of any row and any column is going to be 1. So if I have 3 elements here and I want that sum of them, total of them should be equal to 1, then definitely there should be 1, minus 1 and plus 1. So that minus 1 and 1 will get cancelled. I'll be remaining with 1. What it means is every row and every column should have 1 minus 1 and 2 plus 1s. So one way of writing the matrix is 1 minus 1, 1. I can write minus 1, 1, minus 1. And I can probably write 1, 1. And will it work? Okay, I need to have a minus 1. It will not work. Okay, so just do a little bit of trial and error, and you will realize that the next way I will try it out. I will have 1, 1. If I type minus 1 here, and minus 1 here, it will work. This will work. Okay, so you can see any row, any column, the answer is always plus 1. Right? Now for this, I want to find the determinant. So this is my matrix A. I want determinant of A. If you want to find the determinant of A, we know the process of finding the determinant of A. Let's quickly implement that. It is, we can do it in 2 methods. I will use the Saros rule, 1, 1, minus 1, 1, minus 1, 1, minus 1, 1, 1. I will repeat the first column, 1, 1, minus 1, and I will repeat the second column, 1, minus 1, 1. Now I will take the diagonal elements like this and multiply them. So what do I get? 1 minus 1, 1 becomes minus 1, plus 1, 1, minus 1 becomes again minus 1, plus again minus 1, 1, 1 becomes minus 1, right? And I will use a different color for the reverse diagonals this way. These are the elements of multiplication now. So what do I get here? Minus the first one is minus 1, minus 1, minus 1, which is minus 1. Minus again. Second is 1, 1, 1, which is plus 1. And third is 1, 1, 1 again, which is plus 1. So this becomes minus 3, plus 1, minus 1, minus 1. So clearly this becomes minus 4. Okay. So when this is minus 4, they are asking you the absolute value, which means the answer should be plus 4. The answer should be plus 4. For those of you who forgot the Saros rule, please go back to the determinants video and check it out. I discussed this rule in detail. Right, let's move on to the next question. So the next question is based on the inverse of a matrix. So let's quickly read it. Thankfully, they have given a 2 by 2 matrix. I already mentioned in inverses of matrices that 2 by 2 inverse they might ask because it's very simple. 3 by 3 matrix is not that easy to get the inverse. So usually they don't ask. Anyway, so if you have A, B, C, D as a matrix A, just to recollect, then A inverse will be written as, you will interchange D and A and put negative B and negative C. This will be the adjoint of A divided by determinant of A, AD minus BC. This is the formula. So this matrix is A for you. So you have 2 minus half, negative 1 and X. This is your matrix A. So your A inverse according to this will become X and 2 will interchange, and negative half will get another negative which becomes half, and negative 1 will get another negative which becomes 1, divided by 2x minus product of negative half and negative 1 is half. Okay, so this is your A inverse. So this becomes x by 2x minus half, half by 2x minus half, 1 by 2x minus half, 2 by 2x minus half, and this is your A inverse, and they are saying this is equal to 1 1 2 4. If these two are equal, it means every element should be the same, meaning corresponding elements. So let me take this two or these two and try to equate them. So if I take these two, 1 by 2x minus half should be equal to 2, or 2x minus half should be equal to 1 by 2. I take the inverse of them. So your 2x should be equal to 1, half plus half is 1, or x should be equal to half. So I got my answer of x as half, which is 0.5, option number A. All right. So this is the fourth question. As you can see, there were 4 questions coming only from 2019. That's quite a few questions from the matrices. Next, we go to 2020, which is the pandemic year. If you remember, the total number of questions were halved. That is, instead of 60 questions from maths totally, they gave only 30 questions. So in that paper, this is the first question that came from matrices. Now, the determinant of this given matrix is 0. So I will use the property of determinants to solve it. So what property will I use? I will use the property of splitting of determinants. So A, B, C, A square, B square, C square, and A cube minus 1, B cube minus 1, C cube minus 1. If you do not remember the properties of determinants, please go back to the video and look at it. I can split this as A, B, C, A square, B square, C square, A cube, B cube, C cube, and I can write it as minus of A, B, C, A square, B square, C square, 1, 1, 1. I can do this. Now again, I can take A is common in the row, B is common in the row, and C is common in the row. So from the first matrix, or from the first determinant, I can take out A common. Similarly, from the second row, I can take out B common, and the third row, I can take out C common. So my A and B and C will come out, and my determinant will become, first row A is gone, which means 1A is gone. So 1A, A square. From the second row, 1B is gone. So that is 1B and B square. All this we discussed in the matrix determinant property. So please look at the video if you don't remember these. From the third row, I take out 1C common. So 1C and C square. Minus I have A, B, C, A square, B square, C square, 1, 1, 1. Now, if you notice, these two matrices or determinants look kind of similar. To be very exactly sure, what I will do is I will replace your column 1 and column 3. And so let us see what happens. When I replace my column 1 and column 3, I will get A, B, C, and I will get 1, 1, 1. The first one obviously the first determinant will remain as it is. B, B square, C, C square. Whereas the second part of the determinant becomes 1, 1, 1, A square, B square, C square, and then A, B, C. This is what you'll get. Okay, so I'm erasing a little part of this over here. Right. So then I will go forward in my journey. I will try to make both the determinants same, and you'll see why am I making it same. Then what I will do here is, remember, when I interchanged my row 1 with row 3, one column 1 with column 3, one column interchange will put, if the value of x here, if the original value is x, then this value becomes minus x. You'll get a negative here. Okay, remember that. Now, what will I do? I will now replace these two, column 2 and column 3. So what do I get when I do that? I will have ABC, and I have 1, 1, 1, ABC, A square, B square, C square. This will be as it is, minus 1, 1, 1, then ABC, A square, B square, C square. Now, because of column 2, column 3 interchanging, whatever value is here, I will add another, or not add, sorry, multiply one more negative. So I get back negative of negative x, which will become x itself. So these two are exactly the same determinants. So it did not change. They are both the same determinants. Because you get the final determinant by interchanging two pairs of columns, one after the other. So the negative effect gets cancelled. Effectively, what you will see here, because of that, is if this determinant is value x, then this determinant will also be value x. So basically, you're looking at ABC into x minus x, which is ABC, or rather, if you take out x common, it becomes minus 1 into x. Now, this is given to you as 0. So there are two possibilities. Either you will get x equal to 0 or you will get ABC equal to 1, right? Because product of two numbers is 0, which means either x equal to 0 or you'll get ABC equal to 1. They are asking you the value of ABC. Now, you cannot conclude that ABC is 1 unless and until you prove that x is not 0. Because remember, if x is equal to 0, then it is not necessary that ABC is 1. If x is not 0, then guaranteed ABC should be equal to 1. So how can I prove that the determinant value, that is x, it is not 0? That is what we're going to do now. So if I'm looking at this determinant, so I will erase everything that I've done till now. I hope you followed. So I want to prove that the determinant value of what I have over here, that is not 0. So I will write only the x determinant, or the first determinant. I want to show that this determinant, it is not 0. So what will I do? I will do, first what will I do is I will write R1 as R1, or rather R1 minus R2. So what will I get quickly? 0, A minus B, A square minus B square. Then I'll get 1, B, B square, 1, C, C square. Again, the property of determinants allows me to do this without changing the value of the determinant. Please refer to the property of determinants. Next, what will I do? I will write R2 as R2 minus R3. What will I get? 0, A minus B, A square minus B square. Now again 0, B minus C, B square minus C square, and 1, C, C square. So I can write this. Now I'm not making any more changes. I'm just rearranging the terms. I can write it as 0, A minus B. A square minus B square can be written as A minus B and A plus B. 0, B minus C. And B square minus C square can be written as B minus C into B plus C. And finally 1, C, C square. Okay. Now here from the first row, you can take out A minus B common. And from the second row, you can take out B minus C common. So the determinant becomes 0, 1, A plus B. 0, 1, B plus C. And 1, C, C square. So this determinant, if you try to find, you will get this determinant. It's easy for you to solve it. You will get this as C minus A. So the entire product of x becomes the product of A minus B, B minus C, and C minus A. A minus B, B minus C, and C minus A. Now clearly they are saying that A, B, C are distinct real numbers, which means A is not equal to B and B is not equal to C. So the product of A minus B, B minus C, C minus A cannot be 0 because none of them are equal. Hence you are proving that x is not equal to 0. If x is not equal to 0, then guaranteed A plus A, B, C product should be equal to 1. So the answer here is 1. It's a bit lengthy for a short answer kind of a question, but I've proved that x should not be equal to 0. In the exam, you can straight away go ahead and write ABC equal to 1 because the logic is they are asking you a short answer. There should be only one answer because the short answer is always a number. So you cannot say that ABC can be 1 or anything, which means somewhere you don't have to prove x equal to 0, because they're asking you what is ABC equal to 1, which means the question already is formed in such a way that there is only one possibility for ABC. Because it's an explanation in my class, I'm explaining to you why x is not 0 and why is it guaranteed that ABC is 1. In the exam, you don't have to do all this. Straight away after getting this, you can write ABC equal to 1 and that becomes your answer. Let's move on to the next question. I think this is the last question. There were only 2 questions in 2020 because the total number of questions became half. Okay. So a 2 by 2 matrix is filled with 4 digits. So you have A, B, C, D, randomly chosen from 1 to 6. Then the probability that the matrix generated in such a way is a singular matrix. Now I told you what is the meaning of singular. Singular means the determinant. So if I call this as matrix A, then the determinant of A is equal to, or rather is not equal to 0. Oh, sorry, is equal to 0. Okay. If the determinant of A or any matrix is equal to 0, such a matrix is called as a singular matrix. Now, for you to recollect a little bit, why is it called a singular matrix? Because it does not have an inverse. A matrix whose determinant is 0 does not have an inverse. So actually such a kind of matrix is called as a singular, or the other name used is a degenerate matrix. It's also called as a degenerate. If you remember, I discussed all this in the inverse of a matrix class or video. Now, this is what is given. So first we want probability of the matrix being a singular. Now, the basics of probability tells you that denominator should be all possibilities and numerator should be only the possibilities that you want, that is favorable possibilities. So when you're choosing 4 numbers, or rather arranging 4 numbers, not choosing, sorry, you are arranging 4 numbers A, B, C, D, because a place matters. Where is A, where is B, where is C, where is D? From these 6, the total number of ways in which you can form matrices is 6p4, because 6 numbers to be arranged in 4 places, 6p4. Right? Go back to the basics of probability. Favorable possibilities. What are the favorable possibilities? You want the determinant to be 0, which means AD minus BC should be equal to 0, or AD should be equal to BC. Now, ABCD can be 1 to 6. If you observe a bit carefully, these two, if A into D is equal to B into C, it means there should be something should be cancelling on both sides, or the product should be same. Clearly, the number 5 cannot be possible at all. Why can't 5 be possible? Because this 5 is on left hand side. There is only one 5, because remember, distinct integers. So no number is getting repeated. If one 5 is on the left hand side, where is a 5 on the right hand side? There is no more 5 available for you. So 5 cannot be there at all. 5 cannot be there at all. So your numbers are actually 1, 2, 3, 4 and 6 only. 1, 2, 3, 4 and 6 only. So let's quickly take a look at what's happening. If I start with A as 1. If I take as A as 1, D for Delhi cannot be 2. Because if 1 and 2 are here, the right hand side is not possible to have total product as 2. 1 into 3 is also not possible. 1 into 4 also is not possible. Right? Because if this is 1 into 4, what are you going to have right hand side? Product of which 2 numbers? Only 2 into 2 can give you 4, but you cannot have same numbers coming. So 1 and 4 also is not possible. The next possibility is 1 and 6. If it is 1 and 6, you can get 2 and 3. Right? So ADBC can be 1, 6, 2, 3. In fact, here 1 and 6 can interchange, 2 and 3 can also interchange. So totally you will get 2 into 2, which is 4 possibilities. So for you to understand clearly, I'm writing down the 4 possibilities: 1, 6, 2, 3, 6, 1, 2, 3, 1, 6, 3, 2, 6, 1, 3, 2. These are the 4 possibilities. Right? So A is 1, D is 6, B is 2, C is 3. Similarly, these are the 4 possibilities. The next thing, I want AD equal to BC. Now I finished everything with A equal to 1. Can A be 2? And if A is 2, D can be 3. Then in which case your B and C will be 1 into 6. Again, I'll get 4 possibilities, just like what I've written previously. I will not repeat all the 4 possibilities in this case. Right? So A as 2, D as 3, B as 1, C as 6, you'll get 4. I'll continue my search for A as 2. After D as 3, my next possibility to search will be 2 4s are 8. If I write 2 into 4, I can't have 8 with the remaining numbers. So 2 into 4 is not possible. Then I will look at 2 into 6. 2 into 6 is 12. So 3 into 4 will be 12. So when A is 2, D is 6, B is 3, C is 4. In this manner, I will have again 4 possibilities because 2 and 6 can interchange, 3 and 4 can interchange. So 2 into 2, 4 more possibilities. So till now we got 4 here and 4 here and 4 here. Then let's look at AD equal to BC. 2 we checked for A. Then let's look at A as 3. When A is 3, I can have D as 4. When D is 4, I will be getting 2 and 6 here. So again, these two can interchange. These two can interchange. 4 more possibilities. When A is 4, A is 3, D is 4 is completed. A is 3, D is 5 is not available. D is 6 also is not possible because if 18 is on the left hand side, you cannot have 2 other numbers giving you 18. Next, if you move on to A as 4 and you move on to A as 4, then D cannot be any other number because the only thing left is 6. 4 into 6 is 24 and you cannot achieve 24. So totally you got 4 fours as the possibilities. So 16. So 16 by, what is 6p4? 6p4 is 6 factorial by 6 minus 4 factorial, if you remember, which is 6 factorial by 2 factorial. So that is 6 into 5 into 4 into 3. Right? So 4 goes 4 times, 4 4s are 16. 2 goes 2 times, 3 times. So this becomes 2 by 5 3s are 15, 15 3s are 45. So the answer is 2 by 45. Again, slightly lengthy question. If you are really good at matrices and probability, you should be able to do this in under 2 minutes. Okay. So these are the questions, or these are the type of questions that have come in the previous IPMAT exams. So that is the importance of your topic called matrices, guys. So I hope you enjoyed the entire session on matrices. I'll be taking the next sessions on remaining parts of algebra. So see you in those sessions. You can always reach out to me through my email or through my WhatsApp number. Always happy to help you guys out. So this is Srinivas signing off from Matrices. Thank you, guys.